Hello everyone, I'm Li Ming Huang. We are honored to represent our team to share with you the new feature of Flux 2022. Okay, just let's begin by the Flux part. And as you can see here, I have here is a list for all the new feature about the Flux 2022. And then we will just take a look one by one. And here, the first things we want to share with you is the Flux solver in the SimLab. And as you can see here in the SimLab nowadays, there's two possibilities to invoke our solver, our Flux here. The one is by the electromagnetic solution. That means user will define a traditional electromagnetic analysis. And the second one is to use in the e-motor acoustic analysis. That means the user will use Flux to compute the electromagnetic force for running the NVH analysis. And why we want to integrate it in some analysis in SimLab to run this kind of analysis, because SimLab can provide a single environment experience for the users. And the most important things from our point of view is by using SimLab, the user has more and more possibility to couple it with for other Altair software to run the multiphysics analysis. And what we can do today in SimLab with Flux, there's two ways. The first things we can do with Flux is to run the traditional electromagnetic analysis, including the 3D electrostatic or the 2D or 3D magnetostatic analysis, and also the 2D transient magnetic analysis. This is the first things with Flux. And the second thing is the coupling analysis. For example, when using Flux and Activate, we can easily run an e-motor CFD analysis in the SimLab. And by using Flux and OptiShock, we can run the e-motor structural or acoustic analysis in SimLab. And by our team, we have prepared several tutorials concerning this topic. That means for a new user, he can easily begin this kind of analysis. For example, for the electromagnetic analysis, here we have 5 tutorials already published for the version 2022. And for the multiphysics analysis, Flux X, this new one, we are trying to more tutorial video and the demo case will be coming soon on this topic. And just take a quick look for what it likes if a user wants to run some analysis in SimLab by using Flux. For the motor modeling, he can use SimLab to model a motor and then generate easily a 2D motor mesh. And then in SimLab, we have worked with the SimLab team together to generate this optimized workflow ribbon for the 2D analysis. For example, here we try to put more and more Flux functionality in SimLab, but today, as we can see here, there is this kind of things are available in SimLab by using Flux. And we can also run today the back EMF analysis and the starting current analysis, as you can see here, the post-processing result. And in the 3D part analysis is the same. We import a CAD card and generate the mesh and define the magnetic orientation here, and also the coil conductor here, and then we can generate some result, basic analysis, run the basic analysis in SimLab. And in Flux part, what is new in the version 2022? The first thing is we have made a unified installation package for Flux and FluxMotor. So as everyone knows, the Flux and FluxMotor are developed in the Altair France office. So after 5-year development, nowadays FluxMotor and Flux has already the same installation package. And we also try to provide some the easy access for the user to using Flux and FluxMotor. As you can see here in Flux, today the user has an easy access, direct access to open the Altair Flux motor, excuse me. And in contrast, from the FluxMotor, if user want to run Flux software, he can also click on the Open Altair Flux icon to open Flux easily. The next thing is about the winding proximity effect in the 2D transient analysis. So in the previous version of Flux, the winding proximity defect is already concerned in the 2D steady state analysis. But today we have put this homogenization method in also the 2D transient analysis. So as you can see here, for this kind of analysis problem for the electric machine, for example, if we want to compute correctly the joule losses, here, as you can see here, we have two methods. The first one is to model each wire presented in a little cycle area here, or not. We should try to find out homogenized model. And to date, in Flux 2022, this homogenized model is already available in the 2D transient analysis. And as you can see here in the comparison table, with the homogenization technology, the computation time will be divided by 7 in comparing both two models here. So this is a good progress in this kind of analysis. And the next topic is also about homogenization, but it is for another analysis problem, is for the foil coils, which is used commonly in the, for example, in the transformer, as you can see in the picture here. And what is new in the Flux 2022 is in the 2D AC steady state applications, we can generate the foil coil can be homogenized, as you can see here, to analyze this transformer problem. If not, we should modeling each layer by a coil solid conductor here. But nowadays we can easily use the homogenizations technique to modeling this to have this kind of modeling. And the advantage is obviously is the computation time. Here, as you can see here, for a user, the definition is much more easier, and he will have a faster computation, about save 5 times of the time. Okay, let's move on. The next improvement is about the property of the material in the PySec model improvement. Firstly, we have corrected several bugs in the result visualization here, as you can see in the curve here. And another exciting things I want to share with you is in the sensor here. Nowadays, in the Flux 2022, we have created a new type of the analysis in the sensor. That means nowadays, the user can easily compute the magnetic loss for the stator and the rotor part. Excuse me, and for the stator and the rotor part by using the sensor to define a sensor and then click on the magnetic power, and at the end he can compute easily the magnetic loss. And the improvement, it can be applied on a rotating mechanical set, and also we have enhanced the nonlinear convergence, some issues in this topic here in the PySec model improvement. And the next topic is also a new tool in Flux 2022. Is about the material identifications tool. It is the request for many users here. And as you can see here in Flux 2022, here we have added another tool named material identification. And this one is developed with Altair Compose. That means we have used the Compose to design and to the GUE and the identification method. Here is the interface of the Flux material identification tool. And here, nowadays, there is several models is already included in this identification tool. For example, the analytical saturation plus the new adjustment, the classical one, and then it supports also the Joule afterturn method and also the PySec method. And for the iron losses computation model, by using the identification tool, nowadays there is 2 models are supported, including the modified barroted model and also the lost, the Mills method here. And as you can see here in this tool, it will train automatically the how to say that, the coefficient for the material, and then the user, what he needs to do is just to send a CSV data about the measurement to this tool, and then this tool will train automatically the coefficient, and then the user will click on Save PyFlux files, and then he can use the material model in Flux for the following analysis, for example, the e-motor analysis or something like that. Yes. Next thing is about the free shape optimization improvement. I think in the previous new feature, we have already begin to talk about this new function, the free shape optimization. And what is new in Flux 2022? The first thing is we continue to improve the workflow for the free shape optimization. As you can see here, we have added some more new response on the optimization part. For example, for the torque or something like that in the optimization response, user now has more the choice in the objective here. And once it finished defining the response and the constraint or something like that, it will generate the composed function for the following optimizations. And for this free shape optimization workflow in the Flux 2022, we have provided a tutorial here concerning the free shape of optimization of SRM here. And here we have taken this case for a test. And as you can see here, on this case for this switch reactance motor here, the objective we have selected the arranged torque value as the optimization response, and then the constraint is defined on the torque report. And the objective is to reduce the rotor life of 20%, and also to keep the symmetry of the rotor design. And here is the original rotor design, and at the right side picture here is the optimized rotor design. As you can see here, on this test case, we have successfully satisfied the request for the optimizations. And you can just refer to this tutorial step by step to make a quick test of this new functions, new feature in Flux 2022. And next thing is about the FEMT. The FEMT is the e-machine toolbox. And here we have made some minor and also important improvement for this toolbox. For example, the management of the oct periodicity with the full devices. Also the possibility to have delta connections here. And we have add a progress bar during the solving. As you can see here now, when running the e-machine toolbox, the FEMT, the user could know there is still, for example, 1 minute left for the analysis. And also there is some possibility to post-process without recompute after the modification of the max current, max voltage value here. And also possibility to continue the solving if flux is stopped. That means we have fixed several issues in this FEM tools here. That is not all. We have also working on several topics about inside the Flux 2022, for example, about the user experience here. And as you can see here, nowadays, every curve showing in the solution monitor during the solving process. As you can see here, there is so many curves here. Nowadays, it will be automatically created once the solution process is finished. That means user, how to say that, it won't take time to replot this curve after the solving process. And the second thing is similar, but it is about the sensor value. That means when user defining a sensor before the problem solutions, he can define to export all the sensor value in a CSV files. And this thing is very useful to check the result for computation in a batch mode. That means if we are running Flux in a batch mode without opening the Flux GUI, he can easily get all the sensor value by this minor update for the user experience here. And other improvement, for example, for the meshing improvement, we have for some new feature here, new functionality to generate a layer mesh by some surface region here. And also we have fixed and we have add some new feature in our meshing system to improve the meshing time, as you can see here. In the Flux 2021.2, for this kind of problem, it takes half an hour for the meshing, but in the 2022 we have only 4 minutes is enough to reproduce the same mesh in 2021.2, and this case is the same. This is about the meshing improvement. And for the new tutorial, we have in Flux 2022, we have prepared a new tutorial about Axial flux rotor machines analysis, multi-physical analysis, in consideration of EM and thermal analysis, this one. And this is a good tutorial step-by-step for the user to use this set of macro named macro Altair. And this one is used specifically designed for the Axial FluxMotor analysis. And in this set of macro, the user can easily generate the geometric, the mesh, and the winding for this machine, and then easily define the EM simulation and also the thermal analysis, and to run the map efficiency map computation here. So you can refer to this new tutorial for the use of this macro set. And the last thing is about the Python API. It's a minimum native Python interface to drive Flux. Here we can start and stop Flux by this API, Python API, and execute the Flux command, and also to exchange some data here. And we have tested it on the Python 3.5.4 here. And it is also usable in the compose with the Python GUI. So the conclusion for this part for the Flux 2022 is we have several updates in Flux to improve the modeling capability, for example, for the winding proximity effect for the homogenization here. And we are also trying to give a much better user experience for the user experience, for example, by given a unified installation package for Flux and FluxMotor. And we have also improved and we have also make some improvement in the PySec model, the material identification tools, free shape optimization, something like that. And for the Flux solver in SimLab, we are trying to have stronger connections to other Altair software between Flux and OptiShark, for example, and also Axial by using SimLab. We are trying to use SimLab as a bridge to connect to many more software from Altair HyperWorks to give more and more possibility for the user to run multi-physics analysis. And I think that's all from the Flux part.